Good morning to one and all. In this lecture series, we will discuss about electrochemical machining process. In the previous lecture series, we had discussed about the need of traditional machining process, what is the meaning of unconventional machining process, and what are the major difference between traditional and unconventional machining process. And also, we had discussed about electrical discharge machining process and wire cut electrical discharge machining process. In this lecture, we will discuss about electrochemical machining process. In chemical energy methods, the metal is removed from the workpiece through controlled etching of the workpiece material in contact with the chemical solution. In electrochemical energy methods, material is removed by ion displacement of the workpiece material in contact with the chemical solution. Some of the examples of chemical energy methods are electrochemical machining, electrochemical grinding, electrochemical honing, and electrochemical deburring, etc. First, electrochemical machining. ECM is one of the recent and most useful machining process. In this process, electrolysis method is used to remove the metal from the workpiece. It is best suited for the metals and alloys which is difficult to be machined by mechanical machining process. The major principle of electrochemical machining process are based upon the principles of Faraday's law of electrolysis, which may be stated as follows. The first law states that the amount of any material dissolved or deposited is proportional to the quantity of electricity produced. The second law proposes that the amount of change produced in the material is proportional to its electrochemical equivalent of the material. Basically, in the electroplating, the metal is deposited on the workpiece, while in case of ECM, electrochemical machining process, the objective is to remove the metal from the workpiece. So, the reverse of electroplating is applied in the case of ECM, electrochemical machining process. Therefore, the workpiece is connected to that of the positive terminal anode and the tool is connected to negative terminal cathode. When the current is passed, the workpiece loses metal and the dissolved metal is carried out by circulating and electrolyte between the workpiece and the tool. Next, we will discuss about the construction and working of electrochemical machining process. It consists of workpiece material, tool, servo motor for controlling two field, DC power supply. This is the DC power supply unit, the electrolyte, pump, motor for pump, and a filter and a reservoir for the electrolyte. These are all some of the major parts of the electrochemical machining process. Workpiece, again once again I will tell: workpiece, tool, servo motor for control feeding mechanism, DC power supply, electrolyte which is fed into the tool with the help of pump through the motor, and it is dielectric fluid is passed, electrolyte is passed to the tool through the filter. These are some of the major parts of the electrochemical machining process. A sharpened tool is used in this process. Here, the tool is connected to the negative terminal and it acts as a cathode, and the workpiece material is connected to the positive terminal and it acts as the anode. Major properties of tool: it should have enough thermal and electrical conductivity, it should have high chemical resistance to electrolyte, it has adequate stiffness and machinability. Some of the tool materials are stainless steel, titanium, brass, copper, etc. And a tool, it has an hollow tubular tube through which electrolyte is circulated between tool and the workpiece. Some of the electrolyte used in the electrochemical machining process are sodium nitrate solution, sodium chloride, sodium hydroxide, sodium fluoride, potassium nitrate and potassium chloride. Servo motor, it is used to controlling the tool feeding mechanism, and the filter used to remove the dust particles from electrolyte fluid. The tool and workpiece are held close to each other with a very small gap, that is 0.05 to 0.5 mm between them, by using servo motor. The electrolyte from the reservoir is pumped. This is the reservoir. The reservoir is pumped at high pressure and flows through the gap between the workpiece and the tool, and with a velocity of 30 to 60 meter per second. A mild DC voltage about 5 to 30 voltage is applied between the tool and the workpiece. Due to the applied voltage, the current flows through the electrolyte with positively charged ions and negatively charged ions. The positive ions move towards the tool cathode, while negative ions move towards the workpiece. The electrochemical reaction takes place due to the flow of ions, and it causes the removal of metal from the workpiece in the form of sludge. Advantages of ECM are: material removal rate is high, wear and tool of tool is negligible, machining is done at a low voltage. Complex shapes can be machined. High surface finish can be obtained with 0.2 to 0.8 microns. Very thin sections can be easily machined. Toughness and brittleness of the material has no effect on the machining process. Limitations are non-conducting materials cannot be machined. Consumption of power is nearly 100 times more than in turning or milling the steel. Machining process is comparatively slow. Initial investment is quite high. More space is required. Applications are machining complicated profiles such as jet engine blades, turbine wheels, etc. Drilling small deep holes such as in nozzles. Machining of cavities and holes of irregular shapes. Machining of blind holes and pockets such as in forging dies. Machining of hard materials and heat resistant materials. Thank you.